Characteristics of groups. In the characteristics of groups, we will discuss the variation of some of the important properties of elements like the number of valence electrons, valency, size of atoms, metallic character, chemical reactivity, and nature of oxides. On moving down in a group of the periodic table, that is, on moving from top to bottom in a vertical column of the periodic table, let us start with the variation in the number of valence electrons in a group. Valence electron or outermost electrons. All the elements of a group of the periodic table have the same number of valence electrons. For example, all the elements of group 1 of the periodic table like lithium, sodium, potassium have one valence electron each in their atoms. This is shown more clearly in the table given on the next page. The atoms of group 1 elements lithium, sodium and potassium can lose their one valence electron easily to form positive ions like Li+, Na+, and K+ respectively, having one unit positive charge. So group 1 elements are monovalent, having valency of 1 and ionic in their chemical reactions. Please note that the hydrogen element, which has been placed at the top of group 1 in the periodic table, has also one valence electron in its atoms and also form positive ion H+. We have not shown hydrogen in this table because it is non-metal, whereas all the other elements of this group of alkali metals. From the above discussion, we conclude that on moving down in a particular group of the periodic table, the number of valence electrons in the elements remains the same. We will now take the example of group 2 elements. Here, this is group 1, lithium, sodium, potassium, and then electronic configuration 21, 281, 281, and group 1. So valence electron, number of valence electron remains 1. Okay, all the elements of group 2 have two valence electrons each in their atoms. For example, the elements beryllium, magnesium and calcium of group 2 of the periodic table have two valence electrons each in their atoms. This is shown in the table given alongside. The atoms of groups 2 elements beryllium, magnesium and calcium can lose their two valence electron easily to form positive ions Be2+, Mg2+, and Ca2+, respectively, each having 2 units of positive charge. So group 2 elements are divalent, having valency of 2 and ionic in their chemical reactions. Please note that the fundamental difference between the electronic configuration of group 1 and group 2 elements is that group 1 elements have one valence electron in their atoms, whereas group 2 elements have two valence electron in their atoms. Group 2, beryllium, Be, beryllium, Mg, magnesium, Ca, calcium. Then electronic configuration 2, 2, 282, 282. Then group 2, so valence electrons in the outermost shell is 2. Number of valence electrons 2, 2, 2. Group 13 elements have 3 valence electrons. Each group 14 elements have 4 electrons. Each group 15 elements have 5 valence electrons, and group 16 elements have 6 valence electrons each in their atoms. Similarly, all the elements of group 17 have 7 valence electrons each in their atoms. For example, of the halogen element of group 17 like fluorine, chlorine, bromine and iodine have 7 valence electrons each in their outermost shells. This is shown in the table given on the right hand side. The atoms of group 17 elements like fluorine, chlorine, bromine and iodine have 7 electrons each in their valence shell. So group 17 elements accept one electron easily to complete their octet and form negative ions like Fe negative, Cl negative, Br negative and I negative, having one unit of negative charge. So group 17 elements are monovalent and form negatively charged ions. They are electronegative elements. This one, group 17. So group 17, F fluorine, Cl chlorine, Br bromine, I iodine. Electronic configuration 2, 7, 2, 8, 7, 2, 8, 18, 7, 2, 8, 18, 18, 7. And the number of valence electrons 7, 7. All the elements of group 18 have 8 valence electrons each in their atoms except helium, which has only two valence electron in its atom. This point will become more clear from the electronic configuration of group 18 elements, helium, neon, argon and krypton, given on the right hand side. The outermost shell of the atom of group 18 elements are already completely filled with electrons. These elements have no tendency to lose or gain electrons. Due to this, the elements of group 18 are zero valent, having zero valency and unreactive. Group 18 He helium, Ne neon, Ar argon, Kr krypton. Electronic configuration 2, 28, 288, 28, 188. And the number of valence electrons 2 in case of helium, and then rest of them have 8 electrons, number of valence electrons. Since all the elements in group have similar electronic configuration having the same number of valence electrons, they show similar chemical properties. Thus, elements in a group show similar chemical properties. Please note that if some elements have the same number of electrons and electrons in the outermost shell of their atoms, then they belong to the same group of the periodic table. Another point to be noted is that the elements in a group do not have consecutive atomic numbers. We will now describe how to find the group number of an element in the periodic table from the number of valence electron and its atom. Please note that. So here neon gas is used in advertising signs called neon signs because it glows red when electricity is passed through it, and argon gas is used to fill light bulbs to prevent the tungsten filament from reacting with oxygen and air. Some of the uses of group 18 elements, which are called noble gases or inert gases. So the group number of elements having up to 2 valence electron is equals to the number of valence electron. For example, if number of valence electron is 1, then group number is 1. If number of valence electron is 2, then group number is 2. The group number of elements having more than 2 valence electron is equal to the number of valence electron plus 10. For example, if number of valence electron is 3, then group number is 3 plus 10 equal to 13. If number of valence electron is 4, then group number is 4 plus 10, 14. If number of valence electron is 5, then group number is 5 plus 10 equal to 15. If number of valence electron is 6, then group number is 6 plus 10 equal to 16. If number of valence electrons is 7, then group number is 7 plus 10 equal to 17. If number of valence electron is 8, then group number is 8 plus 10 equal to 18. There is, however, an exception to this rule. The noble gas helium has 2 valence electron in K shell, but its group number is 18. Thank you.